In this video, we're going to talk about refactoring. Refactoring is improving the design of existing code without changing what it does. In other words, it's about making the code cleaner, more readable, and easier to maintain, all while ensuring it functions exactly as it did before. Refactoring is the process of changing a software system in such a way that it does not alter the external behavior of the code, yet improves its internal structure. So, why should you refactor your code? There are several compelling benefits. First, it improves code readability, making it easier for you and others to understand what the code does. Refactoring reduces complexity, simplifying intricate sections of your code base. It makes the code easier to maintain in the long run. Refactoring also makes it easier to add extensions and new features. Refactoring can even help find bugs that might be hiding in the code. When should you refactor? A good rule of thumb is the rule of 3, which means that after you've implemented a similar piece of code for the third time, it's time to refactor. Refactor when you are adding a feature, fixing a bug during code review, and when you have to pay technical debt. Code smells are signs that indicate refactoring may be needed. They are not necessarily bugs, but they point to potential problems in the design and structure of your code. Code smells are categorized into 3 major types. First is bloaters. Bloaters are code constructs that have grown so large that they are hard to deal with. Examples include long method, large class, primitive obsession, long parameter list, and data clumps. Second type is object orientation abusers. These smells indicate that object-oriented principles are not being properly applied. Examples include switch statements, temporary field, refused bequest, alternative classes, and feature envy. Third one is change preventers. These smells make it hard to modify or extend the code. Examples of these are shotgun surgery, parallel inheritance, divergent change, inappropriate intimacy, and message chains. Here's an example of code that contains several code smells before refactoring. Note that it has several problems, including long method, inappropriate comments, and magic numbers. Let us see the code. We have a function named calculateTotalPrice that takes items and customer ID as arguments. It calculates the total price with some conditions. It has inline comments that are not very helpful. It has magic numbers like 0.08, 0.9, 1.02, and 0.95, which are hard to understand without context. The code has a long method because the entire calculation logic is within a single function. There is feature envy as customer ID is being checked if starts with some string. In the next slide, we will refactor this code. This is the same code from the previous slide after applying refactoring techniques. Let us see the refactored code. First, we have created a class called pricing service. We have added constants for tax rate, book discount, electronics fee, and premium discount. This removes magic numbers from the code. We have extracted method to calculate item subtotal, and another method to calculate each individual item's price. In the next slide, we will refactor this code further. This slide shows the remaining refactored methods to calculate prices. We have the apply customer discount method to apply discount based on customer type, and apply tax method to apply taxes on the amount. We have another class customer, which encapsulates customer-related information and logic. The feature envy code smell has been removed by moving the customer-related logic to the customer class. With this, the code now has single responsibility as each method does one thing well. Also, the code is object-oriented with proper use of classes and encapsulation. Here are some common refactoring techniques. Extract method is turning a code fragment into a method with a name that explains its purpose. Rename variable or method is changing the name to better reflect what it does or contains. Extract class is creating a new class and moving relevant fields and methods from the old class. Introduce parameter object is replacing a group of parameters with an object to reduce parameter count. Replace conditional with polymorphism is moving each leg of a conditional to an overriding method in a subclass. Decompose conditional is extracting complex conditional logic into methods with descriptive names. Solid principles are the fundamental principles for maintainable code. SOLID is an acronym, where each letter represents a key principle. S stands for Single Responsibility Principle. A class should have only one reason to change, meaning it should have only one job or responsibility. O stands for Open or Closed Principle. Software entities should be open for extension but closed for modification. L stands for Liskov Substitution Principle. Objects of a superclass should be replaceable with objects of a subclass without affecting correctness. I stands for Interface Segregation Principle. Many client-specific interfaces are better than one general-purpose interface. Dependency Inversion Principle is the D in SOLID. High-level modules should not depend on low-level modules. Both should depend on abstractions. Abstractions should not depend on details. Details should depend on abstractions. Look at the code before refactoring. Notification service directly depends on email sender. After refactoring, notification service depends on abstraction and email sender also depends on abstraction. This makes the code loosely coupled. Here are some tips for successful code improvement through refactoring. Always have tests before refactoring. Tests verify behavior remains unchanged and provide confidence during changes. Make small, incremental changes. Test after each refactoring step. It is easier to identify issues when they occur. Use IDE refactoring tools, leverage linters and static analyzers, and use continuous integration for quick feedback. Have dedicated refactoring pull requests. Separate refactoring from feature work, and document the why behind refactoring. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.